Assalamualaikum and good day. Again, we meet again. I'm Mohd Hafizi. I'm your laboratory instructor. So I'm gonna explain a little bit more further details about the DASYLAB. We have previous sessions, and also I have explained about the DASYLAB, and also in the previous session you already installed the DASYLAB, and for those who have problem installing the DASYLAB, please let me know. Maybe I can help you to solve the problem that you faced during the installation. All right, so I'm not gonna waste any more time because I'm gonna go straight to the DASYLAB. But before we go to DASYLAB, we're gonna see this slide. I'm gonna interchange with DASYLAB and this slide because some of the theory you might need to know before you can understand how to use DASYLAB. All right, so the DASYLAB, basically DASYLAB is a virtual instrumentation software. It must be connected with the sensors. It must have a sensor connected to the DASYLAB, then DASYLAB can work. But DASYLAB also can generate its own signal. So basically, if you don't have sensors, you can still use a signal generator. I have shown in the previous session about the signal generator. But for today, I'm gonna discuss or explain further on the how to use a DASYLAB with the sensors. Basically, to use the sound intensity probe or microphone. For our case, we don't have a sound intensity microphone, but I have microphone with me. I know the specification of the microphone that I have, but we're gonna see how to use this microphone together with the DASYLAB. Alright, so before we go further, I'm gonna explain on the sensitivity. Okay, so we have here the sensitivity of the sensor. So for this slide, I show the accelerometer, but for our case is the microphone. For a probe or transducer, the sound intensity transducer. For my case, I'm the one I have here. I have microphone with sensitivity of the microphone is about 1 volt over 1 Pascal, 1 V over 1 Pascal. So which means 1 Pascal signal will give 1 volt, right? So I'm gonna the DASYLAB will translate this information because DASYLAB only get the voltage, because the sound card of my computer convert the signal from microphone into voltage signal. So voltage signal will be detected by the software, and then again we need to convert into Pascal, or the signal that related to the sound wave. Okay, so basically we assume that we work in this linear range. Yeah, so if not in the linear range, so it's difficult for us to make sure that our signal is accurate. Basically our signal we're going to use in the linear range. Alright, so we go to the DASYLAB. So I have explained about this one in the previous session. So I'm going to go fast. I'm going to stop right. Sorry, not here. I'm going to stop right here. Okay, so I'm going to stop right here. I'm not going to explain this one now. I'm going to explain during the DASYLAB. So I'm going to open the DASYLAB. I already open the DASYLAB. So we have here. Sorry, I'm going to close this one. So I'm going to delete everything. Alright, so we have all these things. You already know that we have this module modules here, and then we have and this worksheet over here, and then we have this is just a notification of what we do. So basically we have two space two space here that related to what we're gonna do. So we have here is a modules, and we have here it's a worksheet. And in the previous session I already showed the layout, how to use a layout, but we're gonna show it one by one. So we have here driver. So we have analog input as the, I'm going to bring in the analog input here because this is represent the microphone, the sound card. Okay, so if I double click here, so it's actually the hardware is sound card. So you can see the sound card here is the hardware. So you can change the name. So I'm going to change the name, so make it interesting. So I put it as a sound card. So see, you can have that name here, and then usually I'll go straight to the display. So I'm going to show you, I'm going to drag in the YT chart to show directly the signal from the sound card. I'm going to link this one to this one. All right, so I'm going to make it a bit distance. All right, so this one I'm going to double click and change the name that I can remember what is this chart for. So I put it signals, or sorry, I'll put it as acoustic. All right, and don't forget to click on the auto scale, and then leave it the others as a default. So okay, so now we have a sound card, and then this is the signal. So we have a restore all windows button here. So that's mean so every time you drag in the one that in this module, YT chart, XY chart, chart recorder, and all these display elements over here, you're gonna open up this window. There's a lot of windows that we can, let's say we take it all, so it will give a window, specific window to that display element. So if you open, let's say we have a 10 YT chart, so it will have 10 windows. So if we click this button, see, it will restore all windows. So if you have a lot of windows, it's gonna be messy lah. So now we have only one, so we have only one here. So I'm gonna play. So this is the signal. All right. So whenever I talk, so it will give the my voice signals. All right, so this is come to the theory parts. So you see here, this button here represent the measurement setup. So basically when we want to acquire signal, we basically if you want to acquire through any kind of signal measurement hardware, we're going to set two things. First, we're going to set the sampling rate. Any hardware have its maximum sampling rate. The higher is better. For this one, we don't know the capability of our sound card, but if you purchase a different card from supplier, it will tell us in the specification what's the maximum sampling rate. So for this one, I don't know. I think all of us don't know the specification of the sound card, the sampling rates. But if you click here, it's gonna show you a default value of the sound card. I don't know whether this is actually actual maximum sound card, but when I test in the previous job that I did, I think this represent the real sampling rate that can be achieved by the sound card. But I don't know whether this is maximum or not. But let us see about this acoustic wave. Basically, when we speak, the normal acoustic signal is about 1000 hertz. It just average 1000 hertz. In fact, this microphone here, whenever you want to give the specification, it will give the specification with the reference of 1000 hertz, because most of the signals is around, sound signal is around 1000 hertz. So let's say 1000 hertz is a signal that we want to capture. According to the Nyquist Theorem, I think you already learned this one in this subject by Dr. Azri. If you don't, just Google it, the Nyquist theory, saying that if you want to set the sampling rate of any data acquisition system to capture signals, make sure that it is at least 2 times the maximum frequency that you measure. So let's say you're measuring the frequency about 1000 hertz. Sound wave is about 1000 hertz. So the minimum sampling rate you need to set is 2000 and above, not 2000, above than 2000. That means 2001, 2002, 3, but not 2000. It must be above than 2000. So if you set 3000, it should be enough. You can capture the accurate signal for 1000 hertz. But that's a theory, Nyquist theorem. According to my experience, the best sampling rate is you need to have 10 times of the signal that you want to measure. So let's say you need 1000 hertz. So 10 times of the 1000 is 10,000. So for this one, for our case, 10,000 hertz should be okay to get the sound wave signal. But this one by default it shows 11 kilohertz, which means 11,000. Just I think it should be, you can leave it as it is as default, because I think it should be enough to capture the 1000 hertz signal. I mean our voice. Okay, now we talk about the block size. So you have there is a block size. So how can we put the value for block size? If you click here, so you can adjust the value. Say if you just click here, so it will give this default value or automatically set up. But I'm going to show you this my notes here. So we have, let's say we have a random signal here. We have random signals, and then when we sample this analog signal into discrete signal, basically it's happen if you convert into digital signal. So let's say you put a lot of dot here to represent the digital signal that represent the analog signal. This dot is numbers of sample per time, which is the sampling rate itself. So the relation between sampling rates and the block size is this equation. So the sampling period, let me show you some drawing. Okay, so the sampling period here is represent the distance between two sample. Say the two sample here, the distance between two sample here is the sampling period. So the smaller the sampling period, I mean the faster it can capture the signal. So better resolution, smaller is better resolution. So let's say we have a Ts as a sampling period. So it's actually equal to T over N, which is T is the total time of the block. This one, this is T. So the whole here is T. So this is T. Divide by N. N is the number of sample. So we have 1, 2, 3, 4, 5, 6, 7 until N number here. So we divide T, divide by N. So you can have the sampling period. And we know the sampling period related to the sampling rate is Fs, sampling period or sampling rate, is equal to 1 over Ts. Right. So that's mean that because the sampling rate Fs is the one we know from the setup, from the hardware specification, sampling rates, or the one that we set. Like for example, just now in DASYLAB, we have 11,000 sampling rates. So it's related to the if you want to find a sampling period, just Ts equal to 1 over Fs. So you can find the sampling period. You can calculate the sampling period. After you calculate sampling period, you can find the total time here. The total time here. Okay. If you set the value n, the block size, number of size, you can estimate the time here for the whole window. Okay, the whole window. Okay, the whole window. For example, if you set 11,025 or 10,000 10,000 sampling rate you set. Okay, I'll go back to the DASYLAB. So let's say you set sorry, where's that? It's 10 kilohertz. That means 10,000. If you had 10,000, okay, so if you choose block size also 10,000, okay, so it will appear the T, the total time, the window time is 1 second. You can prove it here. Okay, sorry. Okay, now. So if you convert this signal, you convert this Ts into sampling frequency sampling rate. So you can you put this equation into this equation. Okay, so you can get this equation. So sampling rate Fs is equal to n over t. So if you want to find t, I mean the whole time here, so you just so t, so I put here, so t is equal to n over Fs. Okay, so n is, for example, just now we set 10,000 as the block size, so Fs also 10,000. So that means the whole view, the whole t, sorry, the time for the t here is equal to 1. Okay, so let's see. So if I can show you, so we set something like this here. So click OK, and then you can see that. So we have a run. So now you see 0 to about, if I can stop the measurement, it's about, this one is about, it's millisecond. So 1000 millisecond equal to 1 second. So see, it will represent the whole block time. So if you want to make it smaller, let's say you want to get about let's say 500 only. So what you're going to do is either you reduce the value for you reduce the value for sampling rate, or you increase the block size. But you know, sampling rates is better you set the high, it's in high value. Okay, 10,000 should be okay, 10,000 sampling rates for our case. Then if you want to get the window time is about 500 millisecond or 0.5 second, so you increase the value for n. Maybe you can set 20,000. So if I can go back to here, I can stop here, and then I go to click here, measurement setup. Okay, I click the block size into 20,000. Either you can click from there, or you can click, you can write down here like 20,000. So either way, say, so just click OK, and then you play. See, you can see, oh sorry, oh sorry, it will give you a double value, so it's 2 seconds, because 20,000 divided by 10,000 frequency sampling frequency is about 2 seconds. So if you want to get 0.5 second, you stop here, you change into 5,000. Sorry, it's my bad, my mistake. So just run and then you see you can have 500 milliseconds. So this is how you set the view of your window, and that is the relation between block size and the sampling rate. Okay, so I have already demonstrated that one for you, so you can use this setting when you want to set up your system later on. Alright, so now we're done with this one. Oh, I'll put it higher. Okay, so I'll make it smaller. So what we're gonna do here is we're gonna you can set a filter. I already explained how to set a filter. No, before we go to filter, we're gonna show the frequency content of the signal. So how to show the frequency content of the signal? I'm gonna introduce you about this signal analysis. We're going to convert this time domain signal into frequency atau spectrum signal. So I'm going to click here. So first, before I have explained to you about the data window, we need to refer to the previous session. We need to cut the window every time you want to convert the signal into frequency representation. We need to cut the signal into a window. So there's a method how to cut the window. We need to properly cut the window to avoid any misleading to the signal. I've already explained in the previous session. So I'm going to get the data window, and I'm going to get the FFT. Okay, so make sure it's a real FFT. So okay, so this is a process. So you don't have to delete this one, you just only need to get this one here, put it here. So now the signal flow from the sound card go to the data window, and data window will cut the signal. So it will cut into block. Okay, so it's dependent on us. So we know that just now we said the block size is 5,000. That's mean every 5,000 if you set here 5,000, so every 5,000 block you're gonna calculate the frequency content, and then it will display the frequency. So I'm gonna use a just a default value 5,000 block size that we set just now. Okay, let me check whether I set it right. So we have now, so we have sampling rate 10,000 and the block size is 5,000. Okay, now okay, done. Enough of that. Alright, so once you set up the block size and make sure that you have proper sampling rate, now you need to put a display here, spectrum. Make sure there's spectrum here, so you double click here, so you make sure they put spectrum, label it as spectrum, so easier for you to find later on when you make a layout or you make your own GUI. There's a lot of windows, so you can recognize this is actually a window to show the spectrum FFT result. And then make sure you click the auto scale. Okay, then press OK. Alright, so we have everything here, and then we just restore all windows, so you have something like this. Alright, so okay, look at this. This 500 millisecond is we already set up by properly set up the block size, so you can have the window time. But look at the spectrum. So how to determine the X value here? So it is actually 5,000 Hertz here. This is because of we set the sampling rate 10,000. If you still remember, we set the sampling rate 10,000. If I can recall again, why we set 10,000? Because of the spectrum that we estimate that we can acquire from the microphone is about 1000 Hz. It's a normal human voice, 1000 Hz. So that's why we set 10,000 as a good sampling rate for our acquisition of system in DASYLAB. And when we choose 10,000 as the sampling rate, of course here it will automatically display half of the frequency, which is if you set 10,000 it will show 5,000. This is because it is automatically set up because it want to avoid the anti-aliasing. This is an anti-aliasing strategy to make sure that there's no aliasing appear in the system. Okay, if you want to know more about the anti-aliasing, you can Google or just refer to the notes from Dr. Azri. Okay, right. So if I run, so this is actually what it will show. The frequency. This is the frequency content of my voice. This is the signal view. It's not really satisfying because it only show a very short range. Maybe I can change a little bit to a bigger window so that I can see a lot of signal. Satisfying to see a lot of signal. So just go to the measurement setup. I change the block size. So block size instead of 5,000 I change to 20,000 so that I can have a view about 2 seconds. Right. So this is what happened. So I can see a lot of my voice here. So you can see, yeah, quite satisfying view. My voice. You can capture the stop between every speech that I said. I come up with. Okay. So look at the frequency. Most of the frequency is around the 1000 Hz. Okay, as expected. Okay, if you want to zoom, just click the button here for zoom. Just zoom in, so you can show the zoom version of your signal. Okay, spectrum. So note that my spectrum view is quite nice because I've used a nice microphone. The better microphone, it will suppress noise. So whenever it suppress noise, it only show nice peak of your voice. Maybe your computer don't have a very good microphone, so it will have a lot of background noise. So it will not showing nice peak like what you see on my computer now. Okay, I just want to stop here. Okay, if you look back to the instruction that I gave to you about the sound level meter that you have to create using the DASYLAB. Okay, this is the instruction that I gave to you. Okay, this is the apparatus. So the objective is to develop the GUI or graphical user interface in the DASYLAB environment for sound level meter. Basically, if you just go to the apps, Google Apps, or if you iPhone, download it, the apps, you can easily download the sound level meter. But usually most of the sound level meter we show only just the value of decibel. Okay, the decibel of the environmental noise or environmental sound around you. But we're gonna build using DASYLAB, which is we can make more interesting, more information in our graphical user interface. So it's better than just only the decibel value as shown in your common apps in the phone. So the apparatus is using a laptop or desktop. Data acquisition is of course the sound card. It's built-in sound card. If you have extra money, you can buy sound card, external sound card. Okay, and then sensor is of course the microphone, either external like the one. My one is mine is external microphone, and you can have your own built-in microphone. It depends. and the software is DASYLAB, of course. The NI-Max here is actually if you have National Instrument hardware, but you don't have National Instrument hardware, so you don't need this one. So you only need DASYLAB 12. All right. So the instruction is choose sampling rate, proper sampling rate, and block size. We have discussed a lot before this, and then select proper filtering. So the filtering also I already explained in a previous session, and windowing, and signal analysis is today. We discussed about the signal analysis, which is FFT. And then after that, when you set up all these things, you just build your own layout that can show the sound level meter. Okay, now what kind of reference that we need to use for sound level meter? This is actually what I found in internet. Basically, if a normal conversation 60 dB, vacuum is about 70 dB, food blender 80 dB, motorcycle 90 dB, jet plane in 100 dB, chainsaw, jet plane. Wow, that's potential of eardrum rupture if you hear continuously. We don't want to have that. But 90 dB also is quite dangerous if we continuously listen to it all the time. I think there is a standard for that. You need to have ear protection. Okay. Okay. So we know that this level. So it's showing all about decibel. So if you refer to our DASYLAB, it shows in terms of voltage. What we see here from our DASYLAB, if I can reopen this. Restore all windows, you can see it, and I can run it, and all value here is in amplitude spectrum. All right, so what happened here, I want to try this. See, captured my clap. Okay, so what happened here is actually it capturing the voltage signal. Right now I'm disconnect the microphone with the computer. I connect this microphone to the phone that I use to record my voice here. The laptop I remain with the built-in microphone, so that will be the same as you. So I expect that result will be the same as you guys. Okay, so if you can see here, here's amplitude. So how to convert this spectrum, amplitude spectrum, into dB or decibel value? What we do is we just stop this one first, and then double click to the FFT modules, and then go to the dB evaluation. So just click enable and look at the value. So this is actually one. Actually, if you click for the first time, it will go to the value 1 because it's a default value 1. But it's if you put 1, what will happen is, okay, and you run, so it will show a negative decibel, because the reference that you put is incorrect. For a sound wave, especially in Pascal, the reference value is 1 times 10 power of negative 12. So it's 1 power negative 10. Oh, sorry, negative 12. So this is actually this is the value in Pascal, whereby this minimum sound, amplitude of sound that human can hear. This is based on the research. That's why frequently we use this value. but the problem is our sensor, our DASYLAB doesn't give the Pascal value. Only if you have your sensitivity value for your microphone, and then you can include to the, you can declare in a DASYLAB, and DASYLAB will show the units based on Pascal. But for our case, we don't know the sensitivity value of our microphone, so we need to make sure that the output here showing the correct decibel. So what we're gonna do is we're gonna play around with this reference value. I have do some calibrations, and the best value for my microphone is 0.04, so that if I click OK and run, it show the correct value of the so it show the correct value of the decibel value. So still I think it's not correct, so I think I need to fix it. Maybe I need to increase a little bit more. No, oh yeah, now it's correct, because usually speech, if you can refer to the website, sorry, you can refer to the website here. The conversation is 60 dB, which means if you can go to the DASYLAB, if you can see it's around, the maximum value is around 60 dB. So which means this is correct. I will show you how to calibrate your DASYLAB with the correct value. After this, I'm going to show you something, and after finish this one, I'm going to show you how to calibrate using apps in your computer, in your phone. Okay, so let us move forward. So this is actually the spectrum spectrum view, but it's hard for us to see the maximum value. We actually interested to get the spectrum, the maximum spectrum, and the maximum amplitude for the spectrum. So what we're gonna do is we're gonna stop here. So this is, if you can refer to this one, this is our window. It capture all the window here. Sorry, this is actually the zoom version, so I'm gonna zoom out again. Okay, so this is actually the value here. So you can see now it is about, this is the maximum value here, my voice. So it's around about 60 above dB. We're gonna see the value here. So how can we do is, we just, this window, we look at the maximum two maximum that we want to see. First, the maximum amplitude Y, and the where the location of the maximum value, which is, this is the maximum value, so the location is this one, so here. So how to get this value is by okay, I just minimize the window, go to the display, get the go to the statistics, get the statistic value. Okay, so bring it here. So this is a process. Okay, so the main source, because we want to get the statistical value from the graph, from the output. So what we do is we connect here. So double click. You can do two ways to connect this one. Either first you just bring this one and connect here. You can do that, or you can do this. Double click spectrum and then go to copy input. Alright, so what it do is it creates another output here. So that's mean that the signal flow in here, and then it, at the same time it come out again at the different ends. So just click this one here. So it looks more presentable, okay, and easy for us to trace. Alright, so now from the statistical value, you can get the maximum value. Of course, this maximum, you just choose the maximum value in that block, which means we have 5,000 block, so in that block the maximum value, okay, so it will calculate the maximum value. And then for the x axis, what we do is either we get another here and then bring in here, click, put here, and double click, we choose the maximum position. Where is the position of the maximum? So the position is in x axis, so it will show you the x axis. If maximum only, it will show the y axis amplitude, and if maximum position, it will show the where the maximum amplitude is located in the x axis. So just click OK. So either we do this, or if you want to minimize the modules, we can do another way, like this one. So I just delete this one, I double click this one, I add one more channel. So this channel is for the maximum value, and this channel is for the maximum position. Okay, so if I click OK, it will appear two channel. So just bring this one, put here. Okay, so we have 0 is for maximum and 1 is for the maximum position. So how can we show this value here, the signal? So we go to the display. We can display in chart recorder, also we can display in digital meter. I'm gonna do both. Okay, I'm gonna do both. So I show you digital meter. So this is display. So and then the other one is the chart recorder. Okay, there's a reason why I do this. I put in this. I think I have re-explained in the first session, where I arrange all the display in one area here, and this is for the signal analysis, and maybe this one is for the statistical analysis. This one for source, the source of the signal. Okay, so now for the maximum value, you can do this. You can double click and then add one more channel for the maximum position. So this one, click here. Alright, and for chart recorder, we will show the, I think what we're interested in is actually the dB value, the maximum value dB. So only for chart recorder, we only record the maximum value only. We don't have to record the where it's located. Okay, so I just click this one. Sorry, actually I remember you can trace the line here. Okay, I click here. Alright, so I have this one here. So if I can maximize all, you can see there's a lot of chart. So chart recorder here. So you cannot do this one. You have to set manual what you call that, manual scaling. So for chart recorder, so you see it's 5, so we need to set for, let's say, the because the room decibel is about 60, so we're gonna make a range for the recorder. So I'm gonna adjust the Y scaling. So I set so the minimum value is 40, and then maximum, maybe I can put 100. So okay, so just it appears something like this. So it will show the variation of the maximum decibel. Okay, so I'm gonna click run. Okay, So now it's showing that this is a decibel value 50. It appears at toward 200 hertz of 500 hertz. This is the frequency that give the maximum value. So this is actually the variation. So maybe if you want to make it more interesting, maybe you can start with 0 for the Y scaling. Start with 0. Maybe it's more interesting to see. Okay, let's run it. Okay, now you see. So it's showing the variation. So let's say if I continuously clap, so it's going to increase the value. Or no, or my clapping is not really high value. Or maybe I should clap here, close to computer. Still, my clapping is not really very high value. Maybe I don't know. Maybe my voice is more disturbing than the clapping. Oh, I think I know the reason why. The clapping sound is only split second. See, if you can refer to if I can clap and freeze a pen, this is where the clapping sound is so small. The area is so small, so it doesn't give any energy, so much energy, so that it not contribute to the decibel value. So if I'm talking, if I'm speaking, so it give, if I can defreeze defreeze, so it will show a large area of sound wave, so it will give a higher energy to our level meter. So what you're gonna do is you're gonna rearrange all these things. Maybe you need to set level. Maybe I can introduce you a little bit more about the bar graph. Okay, so I'm gonna stop here. Minimize the value here. So I'm gonna add the bar graph. So bar graph here. So the source of the bar graph is the decibel value. Okay, so again I'm gonna get this one, put here. So this is one of the display, put it back here. So I need to set up the bar graph. So in the bar graph, just a single value, whatever value come out from the statistical analysis here, it will go to the bar graph. So it's just a single value, so just a bar. So I want the bar type, set the lower limit and set the upper limit. So the limit is we can change, we can set the colors, but I just put the lower limit first. There's a lot of option here, so you can need to play around with the option. I leave it to you. So we have here lower limit. I think it's set maybe 50 as the okay limit, and then 70 is bad limit, which means if above than 70 it can change the color. Okay, so I just click OK. Then you can open this one. So now we show the bar graph. So let me play. So now, oh sorry, I forgot to manually adjust the axis. No, the axis, I mean the scaling. So go to the scaling. So we have again begin with 0 and with 100. That's what we set just now. Okay, so okay, go to here. So now we say here. So you see, if it is in the range, so it is green, but if it is larger than value, so say I move closer to the microphone, so it will give a very high value, so it's red color. So if I can move back from the laptop, so it will show okay, normal value. So if I can go closer again, okay, so this is actually a red color. So I'm gonna bring all these things, put it into our layout. Just stop first, then I go to the, if you remember, if you don't remember, please refer to the previous session. So go to the new layout, go to the, so I just bring it in. So what graph that we need? So we need to put so we have I think we don't need a spectrum here. Nobody want to see the spectrum. We are interested to see the meter, okay, and also we are interested to see the recorder, okay, and also we interested to see, maybe we need to bring one more, sorry, okay, the bar graph. So we maybe you need to rearrange everything, I think. Oh, sorry. Maybe you can put it here. This is just randomly. I do it just thinking instantly, because you know you can put something like this, because if we want to get the equal level here, 100 to 100, and then 0 to 0. So I make it more, okay, and then just put the value here. I mean, you can add your name or your logo inside here. So just run it. So it will show the level. So if I can go closer and then make noisy sound, right, noisy sound. So it will show red color. So again, you're gonna play around and then give it the best display for me. After this session, maybe next session, the session number 3, I'm gonna explain to you about the how to create an interactive layout, whereby you can navigate from one layout to one layout, and then you can save data. Okay, so I think before I end the session, I'm gonna show you how I calibrate the decibel using my phone. Okay, so so this is how I do the calibration. I'm gonna use the DASYLAB setup that we have done just now, and then I'm going to use my phone to download 2 software. Let me see if I already download on the software. Yes, I already download software. So I have the sound meter, and I also have the frequency. So sound meter, so this is sound meter, so it will detect my voice. Okay, so you can see, so this is actually the sound level meter. So what we're gonna do something like this. So it have digital meter, and it also have analog meter, and it show that digital meter. Then a lot of things that we can do here, and then we also need another software, which is the uh, sound generator or frequency generator. So this is a frequency generator. So I'm gonna create a sound, and then the laptop will hear the sound, and then at the same time the phone also hear the sound. Okay, so I'm gonna start the sound. I'm gonna make sure that the computer hear the sound, so I just run it first. So I set the frequency generator to, because our computer here 1000, so I set 1000. Okay, just approximately 1000. Okay, and then make sure that sound is the maximum. And then this is a sine wave.
Get the sound. So move it a bit closer to the microphone. So it shows 83.03. So let me check. I just start to so yeah, move closer the sound to the so this value actually, if I can open the background.
Sorry, worksheet, and then change the value here into 1. So we can open all again and then run.
Oh, sorry. So it's not showing the correct decibel value as what we have done just now. Okay,
So you adjust a little bit by little bit what value that you want to adjust. So what, just like I said, I already do a few tests, and then this is what I've come up with, this value.
oh yeah, I only set up this one. So and again, so 84. Can see the sound level meter connection. So it's showing the same value. So I already got my value. So just approximately.
And then you can when you satisfy with that value, so and then you work out on the apa nama tu, your graphical user interface. Okay, so now we already have this one layout. So let me try with this one.
I move it. I close it.
Alright, so okay, but
One.
okay, so you can test with so many things. You can use vacuum, or you can use lawnmower, okay, or you can go closer to construction area, and then you can do your testing. Make sure that you have a very good graphical user interface. Okay, thank you very much. See you in the next session. Assalamualaikum.